Good morning everyone. Soon as you reach in the stream, don't act new around here. X off the live chat, press like on the video, bring back up the live chat, then we get into it. We're going to put on some good work on Pure Maths Unit 1. And there's this strange phenomenon in maths, at least with CSEC. The harder it gets is the easier it gets, in that the questions, it's harder to come up with questions that there isn't a way to weasel out of the question, especially if you're allowed to use calculator. So good morning Raika, Akinda, Owen, Shania, Kylie, Shemaine, Sharida, Mixed Vibe, Antonio, Vinayak, Anelia, Nandini, Kimaya, Latoya, Caris. What you all can do is just X off the live chat, press like, share the video on your socials now so that everybody could get the notification, them kind of thing. When you share the video using the share option, there's a next thing that it boosts the video for. Like if you click the share and you share it anyway, the people them, things nice. Aruna, Jananda. So we're going to start some pure maths. We're going to be doing all of module 1. That's why it is, right? Module 1, module 2, module 3. So module 1, that's the one with series, sequences, proofs, polynomials, logs, modulus, graphs, some graphs, that kind of thing. And I'll show you what CSEC can test, what they can't really test, because everything on the syllabus they want to test, but something just untestable. It's hard to create a question in multiple choice that is effective. One of them is proofs. So you can see a lot of induction proof and thing, because the answer will give away the question. You'll be able to search through the answer and this one makes sense. Alright. So I always start off with this. I even started off with this in my, some of you all were in my Pure Maths crash course. I started off with this. What represents a demon, because they actually do ask you this: additive inverse, additive identity, distributive law. They kind of want to make sure you know this. So just get this out of the way. The answers for 1, 2, and 3. Additive inverse, additive identity, distributive law, distributive. Are you going to do any unit 2? I don't know if I'll be able to reach the unit 2. When it's unit 2 exam, even if I'm a unit 2 materials. Watching from Guyana. Yeah man, big up. It's not 66 people in Pure Maths. All you had to do, all you had to go and find some people and bring them here. Now it is to run 66 people for a long session. So long we're going for? I'm not too sure. Advertised time is 4 hours. We'll see how long it takes. It depends on how much questions you have. Are you going to do unit 2 right to answer that question? Remember there's a delay in the chat. So answers, are waiting on answers. Betsy, I love you. I love you too. Mark Ramit. 27. Good morning from Jamaica. What countries are they from? As I'm waiting for the answers, yeah, waiting for answers to pop. What countries do you have people from? We have 69 people here right now. What date is Pure Maths Unit 1? I think it's the 27th as well. Right, so I can do module 1 now, swing back in with tricks and thing the next thing, but in a hurry. Unit 2 is the 27th too. So all maths exams taking place on the 27th, every single one. CSEC, Unit 1, Unit 2. Watching from Jamaica. D, so somebody says D, is that for question 1? So what represents a demonstration of the additive inverse? Which one of these? So question 1 is what letter? Question 2 is what letter? Question 3 is what letter? Trinidad, Jamaica, Barbados. Unit 1 is 29th. Okay. St. Martin. What I want you all to do too is pay close attention to what happens in CXC Maths on the 27th. If you hear everybody bawling about, oh my god, new questions, well, you know, accelerate our revision. If you hear people saying same old, well, you know, study along the same old. Working calculus, yeah, we'll come to that, but not today. But I could probably answer 1 or 2 questions on calculus after we finish. Alright, so I have a full answer here. Kylie says 1B, 2A, 3B. 1 is B, 2 is A, 3 is B. Oops, slight spam. B, 2A, 2B, 2C. So I have 2A, 2B, 2C. I didn't want to. Alright, well, everything. I want to make sure that this video has everything and everything feels comfortable for everybody. So if you have any little problems, we're doing it. We're taking your time and doing it. So identities. What do we mean when we say identities? Everybody remember the matrix identity? Right. If you're in unit 1, don't bother about it. You don't need to know that for unit 1 pure maths. But identities is something when you perform the operation on a number using the identity, nothing happens to the number. So let's say we have the additive identity. Additive identity. What is the additive identity, people? What is the multiplicative identity? Multiplicative identity. Ooh, I have a serious like a sleep thing going on here. Identity. So I run in on automatic. So things like writing and spelling and things. Yeah, additive identity. Additive identity, that is the number. When you perform the addition operation on it, on any number, the number doesn't change. So in other words, A plus the additive identity is equal to A, or is equal to the additive identity plus A is equal to A. Sometimes I write it out fully like that. So the additive identity is 0. I see people saying that in the chat. And what's the multiplicative identity? Now I'm not going to put add because we're in multiply land now. So multiply by the identity is equal to the identity multiplied by A is equal to A. Nothing happens when you use the identity. So this is how we describe the identities here. This is how we describe it. And you should know this because they could just throw this out at you and just ask you which one is showing a demonstration of the additive identity. They have been known to do that for many years. Which one is showing an multiplicative identity? Not to be mixed up with the inverse. This is free max, but you can do dumbness and just lose a max, strip it. So don't do dumbness, y'all. Like this free max. This is just pure memorizing here. So identities, what else? We have inverse. We have inverse. So how do we demonstrate the inverse? The inverse renders the identity. When you have a member of the set, a member of the domain, and you perform the operation using the inverse, you will bring forth, you will birth the identity. In other words, if we in the additive inverse section here, right, and we have the same A, and we say we're going to add on the inverse, we're going to bring forth the identity. What is the identity? 0. So what we can add on there to give 0. You understand what I'm saying? So the additive, the inverse gives you the identity. When you perform the operation using the inverse, out pops the identity. Same thing with multiplicative. So there's no pure maths, but you don't know how to spell. Multiplicative. So, and out pops the identity, the multiplicative identity, or the additive identity in this case. Alright, Alright, so do Unit 1 Physics Marathon. When is physics? Multiplicative identity thing, so people answer any question. Negative A, yes. So the additive inverse is subtraction, the negative sign in front of the A, in front of the number, in front of whatever the member of the set they're using, member of the domain. The multiplicative identity is physics and geo marathon. I don't do geo for keep, so that dead. But physics physics CSEC and geo CSEC, yeah, that would be new. You just predicting, and nobody knows. I don't have the paper. I'm not going on a record saying I know exactly what's going on coming on. But I mean, you could just look back in the channel and see how sweet my predicting skills is. Dopa negative here. I was distracted by Videsh. So this is 1 over A. Because this will cancel and I will pop that. So we have the multiplicative inverse, the additive inverse. Inverse should be written here. And we have identity. The next thing the question mentioned was the law. I think it was distributive law. That's the third question. Distributive law. Distributive law deals with how one operation is performed across another operation. How it is the rule governing, can an operation be distributed across another operation? For example, A minus A, sorry, let's just be normal. A multiplied by B plus C. So easy now, this called easy, my boy. I gotta put this on airplane mode or something, I think. Boom. No airplane mode. I disconnect from the internet. That was not a big brain moment day. Earlier. Reconnect. Alright, we're back in the dance. So the distributive law here is the rule governing how multiplication works across addition. It doesn't need to only be multiplication. In today's set, we'll come across how the distributive law works in logic, which is important, like with them and our or thing, injunction, conjunction, disjunction. We'll come across how the distributive law works there. But the distributive law is this here. The law with the brackets now, but so them brackets there. What are the two other laws? You should know the two other laws too, they can pop. Not today, please, not today. This thing real tripping on me, boy. Close off that. AB plus AC, right? What are the other two laws? What are the other two laws, people? So we have the associative law. What else we have? So I feel you get some inside story, you know, sir, about questions will be new, but they said it was set before COVID, and I will be thinking. The paper was set before COVID, but even from January, it seems to be like they're updating the question bank. So I wouldn't bank two things. A lot of these solutions are passing wrong online. Wrong. Well, I wouldn't say wrong and all wrong, but it has some key questions that are wrong, and just people just memorize those solutions and just not do well. Especially if they bring back the tricky questions that are wrong. Commutative, well done. And also from January, it seems like they're not going to go into the thing where they're repeating. Like in pure maths, sometimes they repeat like every single question in pure maths is a repeat. But I feel they're updating. I feel they're putting some work and they're updating. Associative law, commutative, commute, go in, direction, how you go. Commutative law deals with order. Associative law associate, we associate with the group. Associative law deals with grouping. So A, B plus C. So associative law is saying that this is the same as A plus B plus C. Right? I just put the equal in between this. Or you can, associative law works multiplication. Doesn't work for subtraction, doesn't work for division. And the commutative law is order. So the associative law, you can remember, this is the one of three terms we involved in. Right? And the commutative law now, commutative law deals with order. So it means like the direct, which one comes first? A times B is the same as B times A. It doesn't matter if you swap it. What is one thing that is not commutative? And you remember something that's not commutative from CSEC. So you can do apply revision. Well, you're asking a lot. These days are jam-packed because I have 2 classes, CSEC, with lots of students. So it'll be lots of work. So they could also bring back January 2020 new questions. And morning. Good morning everybody. Good morning everybody. Yo, we reach 100 people. Bless up. All the new people on the stream, don't forget to press like. Remember, the pure math squad is not as big as the math squad. I think we already cracked 800 or something for the season with the math squad. 800 live viewers. Pure maths. You holding down at 100. You see how much I've been out here to the end. Something that's not commutative, division, subtraction. Another thing that's not commutative is matrix multiplication. Matrix multiplication, and remember that? If the order is important. So, right. PB developed, boom. Alright, so we can go back to the question now. So the additive inverse here is not this. This is the additive identity. So this is the additive identity, green. You see why yellow now. This, you see here that x and negative x, 0. So when you add on the inverse, out pops the identity. So this is the additive inverse. And yellow. So let's bring up blue now. So blue, the distributive law has the bus open a bracket. So go. Now you did. Alright. Why is in the chat if you all understand that? Swipple, let's put the letters. A, B. So this is like a 2 marks or a 1 mark lock. They must ask you some ridiculous easy question involving this. Lock that mark. I don't think it have any real tricks in this. Just memorize it. Memorize what shows it. They could not use X. They could use A. They could not use A. They could use like a number like 3, 4, 5 plus negative. They could use something like that just to show that you understand what inverse identity the laws talk about. Additive and multiplicative. You're comfortable. You're outside. Can you do this question? Now you're in the corner of a lot of the questions. I'll put a little, you'll see a little red thing here that just to help me remember to show you that there's a shorter way to do these things. Oi, 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 oi. Let's delete some of these windows. Now we get some answers for fauna. So a lot of you all here will be, yes, the live will be available afterward. A lot of you all here may have known me from last year. So I'll probably done have this calculator already. This is one of the better calculators that I recommend. Once you have a nice scientific calculator in pure maths, you're good to go. This is the next nice one. I think I have some high-end sharps that could do a lot too. What is the difference between pure maths and maths? Pure maths is CAPE and maths is for CSEC. Definitely you in CSEC. By the way, people who watching the stream right now, this is a CAPE thing. I write CAPE somewhere and I think it's on the thumbnail. So this is just straight up in your calculator, you know. if by chance you calculate a cutoff, I'll show you how you work with search without using a calculator. Zero, a big fat zero. Cool, we take in that. So you can just, once they give you this, and feels like every year we get in questions like this, getting questions like this, we just numbers, just think to put in your calculator. It's just think to put in your calculator. I don't understand. Like, what we know here. But anyhow, if you had to do this like in a paper 2, or you couldn't use the calculator for some strange reason, what you look for is, you know, break this down in like the same format. And even then I would tell the student to use the calculator to help them. But I can see like this is 2 times 25. This is a square. You're trying to find the squares in them now. This is like, all of them is 2. 2 times 16. 81 by 2. 81 by 2. 2 times 81. You understand? So now, in other words, this is the square root of 2 times 25. And I'm going to show you a little trick here that is important. Now, there is a way that they can bring this, and I think I arranged a question like that, where they don't put numbers, like they put a letter in it and they ask it to simplify. Even then, you can still gangster the question a little bit with your calculator. So 2 times 16, I've seen like a lot of people from maths, because they'll see notification and pure maths. And if there's some kind of fancy term for CSEC maths or something, click on that. Nope. Rewind. So 2 times square root of 2, square root of 25, square root of 2, square root of 2. When it's like this, you could actually separate diagonals, square root of 2, square root of 25, like this. That is allowed. You can verify that on your calculator. Plus, you know, square root of 2, square root of 16, minus square root of 2, square root of 81. So, square root of 25, the reason we're doing that is because square root of 25 is a clean flush answer. 5 square root of 2 plus 4 square root of 2 minus, what the hell is this? 9 is 81, 9 square root of 2. It's gonna be a rough day, man. So this is 9 minus 9. You can think of this as 5 apples plus 4 apples, take away 9 apples, you know? Don't let them squirt thing hot up your head. 0. Could work out to be anything. So questions like this is likely working on the side here. But just rough up this question with your calculator and then come back and see if you can figure out the working and have some fun afterwards. But you know, calculator thing, easiest thing of them all. Oh, now it's time to talk about a little thing that they do in this pure maths. A little thing that they do in this pure maths, boy. Remove context. They like to remove context from the question. In terms of, in the CSEC maths exam, you have the topic of sets, cool. Sets question, done. No more sets question. One is the tricks question, no more tricks question. Whatever. No more that question. Vectors and matrices, bring up the thing, right, cool. In pure maths, they like to sprinkle modules, they like to intertwine the modules. That makes it so that you're not in the chronological order in which you learn it. So sometimes you're doing through module 2 and bam, out pops a differentiation integration question. Or you're in indices and analogs coming, or you're in polynomials and analogs coming. The reason they're doing that too is to remove the context from the question. So you don't know whether to integrate or differentiate, you don't know whether, you know, kind of mess you up there. You don't know whether you're in tricks, so to make sure you understand what you understand. But after you're done with these sessions that I'm doing, we would destroy, especially if you go and practice on your own. A remainder of negative 35, we're waiting for answers from here. A remainder of negative 35 is obtained from, right, remainder and factor term. You know, I didn't prepare much questions on remainder and factor term because it's just get put out so much times. all you need to do is go and watch the first admats live. Negative 4 is 4, negative 4. Shania, not this morning. I tell you, not this morning, Shania. So, go and watch back the admats, crash the admats marathon that I did last week. I think I do that. And I do a good bit of remaining and factor theorem and all that could come in that. But I'll just browse this topic. I expect that you understand this by now. If it could be divided by this, you substitute the plus 1, well not the plus 1, it's either inverted. You substitute the negative 1 in there, Zion is awake. You substitute the negative 1 in there and you will get 0 if it was exactly divisible. But since it's not, since it's even a remainder, when you substitute negative 1, everything's supposed to boil down to give you negative 35. Now, why am I substituting negative 1? People, remember, if the factor was like 2x plus 3, what are we going to put into the equation? What are we going to put into the equation? F of what? If the factor was like, or if what we are dividing was like x minus 10, what are we going to put into the equation, people? F of what? What are we going to put into the equation in terms of x to equate to the remainder or to equate to 0 in the case of a perfect factor? The law for this is if ax plus b is a factor of f of x, then f of negative that b. And if there happens to be a a that is not 1, divide by that a, is equal to 0. Now if it's not a factor, if it's a remainder, if it divides, gives a remainder, when it divides into f of x, it gives a remainder of, let's say, p, then it ain't gonna be 0 no more, it could be p. That is it. The remainder factor theorem is food when it comes to multiple choice. So if it's 2x plus 3 is the negative of that, the additive inverse, if you wanna, use the big boy terms and thing. Additive inverse and divide by this. And this one, additive inverse of that, so you're going into positive land now. And you divide by that, so you put over 1. But nobody's in the right minus over 1, right? So it's 10. So in this case, you're substituting negative 1 in this. With your calculator, beat out that. So your negative 1 cube, negative and cubes is how little games and things play with students, right? Don't let that outgame you. Negative, why I put 2 there for why? Negative 1 in everything, all the x. You're replacing all the x's with negative 1 plus 6 by negative 1 minus 24, and this should be equal to 35. And in essence, what you have here is a linear equation, unknown k, find for k, easy thing. So what's your favorite subject? Is it maths? That's a good, interesting question. Shouldn't I am making an admin here because I've seen people getting out of hand. If people get out of hand, you know what to do. Who else I know around here? Could be admin out by. Yeah, so like when I turn in, if somebody's saying wants the ridiculousness, like kudos can here could take a little break. Take a little ease up there, brother. Alright, so back to maths. So negative 1 plus, well, plus k plus, well, let's put negative 6 minus 24 is equal to 35. Now looking like we reach all the way up to negative 31, right? K take away 31 is equal to 35. Did we now? Oh, it's negative 35. Oh my bad. That'll be a little scary. Negative 35 Everybody see that negative 35, negative 35. So why is it positive? Yeah, I just left out the negative here. And bring across that k is equal to negative 35 plus 31, which is negative 4. Hey. Any questions on this? Write in the chat if you understand this. If you have any questions on this, ask a specific question, because I don't think I'll come back to this topic. Now they can do this, and the way I see they can do this is with a simultaneous. Instead of having k alone, they might have p and q, two things to find, and they'll give you two equations. So you'll end up with a simultaneous equation in the end. By the way, if you end up with a simultaneous equation, you can still use a calculator to solve simultaneous equations very easily, or to help you crunch the numbers in simultaneous equations. 5, going to press 1 here, and you just put whatever is in the equation. 6, 10, understand? Negative 4. You put the coefficients of the x, the y, and the one that's standing by himself, and you'll find your x and y very quickly. Because remember, you have your calculator in this exam. I already have a video on using the calculator, and you can always search up the name of the calculator, and there are videos on YouTube with it. But specific to CSEC pure maths, I will do a video soon. I have it in the works already. I'll do another one, but I already have one where I went through everything, but I didn't really explain how I get each function. Alright, next question. Number 6. The sharp calculator can, it depends on which sharp you have. If it's like the, I think it's the 5 or 6 sharp, the sharp with the solar panel, I think you go in mode and you go in equations as well, and you can pick out, you can do quadratics and simultaneous. So slowly do that again. Oh, I want to see me do the simultaneous. I am saying in a remainder, okay, as I say, it's a session. Anytime you don't know anything, ask and I will help you. So let's say you have they give you a remainder theorem question, and they say x plus 1 is a factor of, just now I'm going to make the equation here, I want to make a nice equation. So when I explain how to do the simultaneous in the calculator, if you were given a polynomial with 2 terms and that comes, I just didn't prepare a question because I thought, forget that. X plus 1 is a factor of Alright, 2x squared minus plus ax plus b, ax cubed, 2x cubed, and next one, how about x minus 8, what was this? I'll just give me 2 minutes to just create this question, right? Just taking some time. I give myself 1 more minute to come up with a decent question. Yes, you lead Lavinimo. It seem to you things are you going to do only pure sessions or is this the only? Yeah, I'll definitely do at least two more pure sessions. And I'm coming up with a good question because I think I start with a bad equation. One last try at this. Yeah, should I do this at my own time before I start? Quotient and alright, I think this could work. And x cube, I tell you, attack this question, minus 14x squared plus ax squared minus b divided by x plus 1 gives a remainder of -3. Right, so something like this could happen and then they ask you to find the value of a and b. Yeah, a simultaneous polynomial was a little scene. So x plus 1 is a factor of 2x cubed plus ax plus b. And x cubed plus ax squared minus b divided by x plus 1 gives a remainder of -3. So they'll ask you, like, what is the values, and then they'll give you some choices. What are the values of a and b? Why isn't the chat if you could do this question? So I'll go through this question and I'll show you how to use the calculator to come up with, to solve the simultaneous equation quickly in your exam. Yeah, I just hope that this works out. Yeah. This one doesn't, but this one does. Right. So yeah, this should be solvable. Let me see if you have anybody here who could handle this. If you can handle this, you're pretty safe. Oh yeah, they can do it. Alright, handle it. Now they could ask this in admaths too, you know. But I don't think they would. But they could. So if you could do this, I guess you're ready for remainder theorem questions, factor theorem questions. The other style you'll do is like this, where it's straightforward and you just find in one missing variable. This one you could find two missing variables. Another thing they could do is ask you which one is a factor. It's not solvable. I'm going to solve it just now, but let me just verify if it's not solvable. Yeah, I think it is solvable. Let me see. I'm not getting an answer. B is a plus 2? How could x plus 1 be a factor and never remainder at the same time? No, this and this is two different equations. So you're not reading it properly. I get the same thing, A and B cancel. Okay. Alright, Ali, if I solve this, well then we need to do our next one. If it didn't solve, well then all else did. If I solve it, it means that well, I need to put in some work. And then also try next one. I feel like I could get some more too. Change one power, ax squared minus b, just verifying this again. Alright, so if x plus 1 is a factor, x plus 1 is a factor, it means that this is 2 by negative 1, because you're substituting the additive inverse, right? 2 by negative 1, I'm substituting into this, and I'm using negative 1, right? Cube plus a by negative 1 plus negative 1, all meaning not solvable squad. No, just b, sorry, just b. B is equal to, nobody hit my answer yet, so maybe it is not solvable. And this is negative 2 b minus a. I just negative a, switch them, right? If anything going too fast or anything missing out or anything, just let me know. So this is one equation, b minus a is equal to 0. Or I could put negative a plus b, wherever floating the boat here, is equal to 2, sorry, bring across the 2. Why is in the chat if you all got this equation to work with in the beginning? And the next part says this, I'm going to copy it and put it on the next page. Anyhow you take it, we learn in here, this is the method. Still didn't see no answers. So if this gives a remainder of negative 3, it means that if I substitute negative 1 in this, negative 1 cube plus a negative 1 squared minus b, I'm supposed to be getting negative 3. So this is negative 1 plus a minus b is equal to negative 3. So this is a minus b is equal to negative 2. This is equation 2. Why is in the chat you all got these two equations? Somebody getting A equals 0 and B equals 2. Which is not what I said. When I said the question, I didn't say A to B equals 0. To me, I said A to B equals negative 14 and B to B equals to negative 12. But we can see A minus B is equal to negative 2. So let's bring across the first equation now. Copy. They cancel it. Feeling like a cancellation vibes going on here. Multiply everything by, yeah, again, a cancel. Infinite solutions. You know what this is telling us? Because I said the question, any value, these two lines touch, these two lines run right through, they're the same. So because I said the question, I didn't get time to check through the answer and make sure that it doesn't have an infinite solution in case that happened. Alright, let me see if I can find a question that would not have an infinite solution. Oh, I wanted to show you how to, forget that, we're just trying to learn something here. I wanted to show you how to do it on the calculator. So like after you solve the equations and you're reaching this scenario and you have the two equations now. Equation 1 and 2. All you need to do, especially if the equation is complicated and you want to just get the answer fast, you bring up your calculator and the simultaneous part, you press mode, equation 5. It may be a different number on your calculator depending on what calculator you're using. And number 1 is the simultaneous equation here. If you're trying to find the if you're trying to solve with 3 unknown variables, that'll be number 2. Don't think you will get that in your exam. So let's see what the calculator will give us for this. We might get a math error for this equation here. So I'm going to press 1. And now I'm pressing the coefficients. So that's negative 1 and 1 equal 2, right? Negative 1, 1, 2. And now I'm doing the second equation, which is 1, negative 1, negative 2. Infinite solution. Right? Infinite solution. Why isn't it if you understand that? So if you have this scenario, that could be an answer. This could be a question as well. Show that they might put that. I want to say show that, but that's paper 2. Paper 1, you may have the infinite solution, and all the rest you have finite solutions. So infinite solution is an answer. What are the values of A and B? Infinite solution, so A and B. A lot of things can take place here. You do your factor business. If you had to do a remainder business, you do your remainder business, you dump out your 2 equations in the end. Keep in mind I stuck in this equation from before and you solve simultaneously. The next thing you can get with remainder and factor theorem is where you give an equation and they say which one of the answers A, B, C or D is a factor. And next kind of easy thing. I think we can move on now. So you're coming into logic. To be honest, logic was something that I crammed off in KB. But only when I became a teacher, I was like, alright, I learned the intricacies of this. But other than that, I just crammed it off. I'm going to show you, I'm going to try to explain the entire topic to you. But let's do this question, please. C? That's correct. Who says that? Who said that? And 6C, Nafisa in the dance, right? So yeah, and this is a question that they always asking because The inverse, converse, and what's the next thing? Inverse, converse. It's slipping me. Inverse, converse, contrapositive. They're always asking that. Contrapositive, converse, inverse. Them three things, they love it. They love it. Well, let me do the quick logic breakdown now. Everybody know this sign is like not. So if it was true, it turned to false. If it was false, it turned to true. In logic from computers, if it was 1, 0 is 0, not, right? Not, gate, whatever. So negation, not. This is the and, similar to and in sets. By the way, you can use sets to solve at least 1 or 2 questions that comes in logic. And I'll show you how to do that as well. Contrapositive, everybody see contrapositive already. And this is your or. Similar to union. So disjunction, conjunction. Nothing too big to memorize. Everybody's safe with that. Everybody understand how those work as well. And means that both must be true for the result to be true. Or anytime one is true, the result is true. Did I put the truth table so both of them? Anybody need me to put the truth table so this? Should I put the truth table so them? This one will just swap it, right? So like if we're using like if the P, the statement is 1, 0, not P will be 0, 1. Or when you do it, we don't use zeros, I always go to zeros. True, false, false, true. Not P, right? Yes, do it. No, not really. Yes. One person say yes. We have whole day. Somebody say no, nah. So more people saying yes. So let me just do it fast. So with the and, you need 2 sets of statements. You need the P and the Q. We're always using P and Q. By the way, I am a person like to teach students to fish and not just to be thing. So this site, Wolfram Alpha, all my top dog students is real play around with that site. Sometimes me and them be playing around with that site. A lot of the questions you can just put directly into that site and see the working, and anybody know this site, help you break down the scene, the scenario. Even logic questions. P, what are we doing? And first. So this is how I do this. I do true, true, false, false. I hope I remember the correct thing. And then I say false. No, I normally start off with true. True, false, true, false. If it's 3 things, well I'll go true, 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 false, 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 and then do true, true, false, false, true, true, false, false, and then the next one I go true, false, true, false, true, false, true, false. That way you don't miss out anything. But you all need to worry about the 3 because they're not bringing that for multiple choice. This is as terrible as it gets with just P and Q. Unless you need to break down something, and even then you don't need to use the truth tables. So this is true and all the rest is false. Now because only this one will give you the true, but and means that both of them must be together for it to work. Both of them must be coming through the circuit. Both of them must be giving me 1s for a 1 to come out. Both must be on for on to come out. If it's or, anytime I true touching down, I'm taking it. or anything working with or anything. Alright, you it have a true here, true. Have a true here, true. Look at true over here. True. No true, alright. Yeah. So you see that's how the or and work. This is the idea behind the, what you call it, a truth table. I see now all the time, right? Truth table. Sometimes I just kind of cross it with yeah, truth table is the word we use with physics. So I'm confused. I don't like the I'm confused talk. I just like to hear questions. Why we cannot use 1 or 0? We could use 1 or 0, but just the convention for keep is T, true and false. So I just stick with keep convention. right? Like in logic for physics, we normally use ones and zeros. Nice. Shania, your job going to be busy day. Let me, some of these people can take off a little high. If you're over spamming, I'll just hide it, right? So don't overdo it. Next. Oh no, I did write something so I just put it back in for fun. Kerwin of the past did try to do a little something here, man. Well done, Kerwin of the past. And this one, true, false. Cool. What about this one? What will be your result? I never really see them ask a question saying, what will be the result of this? Like, give you the truth table. But it can come. I mean, it's a nice multiple choice question. Like what? And then they put true, false, or that true, you know, something simple, or even something not so simple. To go through well with this question, I would segue this across a little bit and sneak in not Q first. So not Q would swap up everything here, understand? So false. I know some of this should just be revision for you. And now you have the and. And now we look in. So false, true, false, false. You understand why I get true here? Because the and I'm looking at. So false, true, false, false. If they wanted it in order, like based off of the table there, they'd have been marking for order. But this is the results we get. We are finally getting different answers, guys. Guys in the chat, if you understand this. Rate this what we do so far out of 10. This little piece of logic. Still have a big jump to go again. And I'll show you the style of questions they ask. We already do one type where they ask it just contrapositive, converse and inverse. They just ask it as straight up. So memorize that. Just memorize this question for me, please. The inverse of P implies Q is this. Let's drop some, and I'll give you a shortcut to remember that. Alright, so this is a conditional statement here. Conditional statement P. If P happens, then Q will happen. If P happens, Q will happen. You understand? Conditional. All this are teaching is just for 2 Scranton marks. It's just for 2 Scranton marks in the paper. But you want them 2 marks, right? If you study, then you pass the exam. So this is like a P, and this is like a Q. Conditional, right? Now with the conditional, they will ask you 3 things just straight off the bat. So ducking that question, boy. When you're doing paper 3 for maths again, or paper 3 for maths is on the 14th, that is next week or some kind of thing. CSEC maths you'll duck them out. So hopefully I can come in with a paper 3 for CSEC maths Sunday or Monday or something like that. I'm definitely doing something. I must be in that. I can be in that set. Contrapositive, reorder, negate. Right? So the contrapositive. This is the short. This is what I told you online class. Anybody from the online class to help remember this. Contrapositive, reorder and drop some nuts. Reorder and negate. So P implies Q, swap it and negate it. Because the contrapositive must mean the same, it must convey the same idea as the statement. P implies Q. So logically they are the same. In other words, if you study, then you will pass. Now if I swap it and not it, let me write it down. Let me write it down. If you study, I write it in short, right? Then you pass. So the contrapositive will be like if you, and I need to swap it and not it. So reorder and negate. If you not pass, then it's because you're not studying. So I switched it, and it did, both of those statements mean the same thing, and both of those statements will give the same truth table, will give the same result on the truth table. Contrapositive, that's contrapositive. Contrapositive is the only one you're doing two things, reordering and negating. Good? You can memorize that, you can come back to this video, memorize that, you can write this down, memorize that. Converse, just reorder. Don't rush the brush with check. Converse, just reorder. So converse, if study then pass. Converse means if you passed, if you pass, I just write in shorthand. If you pass, then it means that you did study, right? This does not mean the same thing as if you study then you pass. This saying that you're only passing because you studied. If you pass, then you study. You pass because you study. The initial statement is saying that if you studied, then you will pass. But you can still pass without studying. Tricky. You could go into the logic tables to see it, but that will be like the whole lesson there. Or you want me to go into the logic tables, or you can just memorize it. You don't need to let me know if you all want more or you'll need more out of that. And lastly, the inverse is just negate. So the inverse is, and this is what I like to ask, inverse. What is the inverse of P implies Q? Just negate it. That's it. And walk away with that marks. Alright? So once again, contrapositive, you need to do the two things. You need to switch it and negate it. Converse, you just need to converse, you just need to switch. And inverse, you just need to negate. Yeah, so contrapositive is like doing the converse and the inverse. Alright, let me move on. This is the if and only if. I never really see any questions on this. I remember, I never really remember anybody seeing any questions on this. So never hear about any questions on this. Now this could come like in your paper 2, but paper 1, if and only if, a nice sweet statement. It means P implies Q and Q implies P. This means, it means the normal statement and the converse at the same time. So the converse and the normal statement at the same time. In other words, this means P implies Q and Q implies P, which makes the statement a little stronger now. So if you study, then and only then, or you understand, if you study, only if you study, you will pass. That is biconditional. That is biconditional. Did I say biconditional in the beginning? That's a biconditional statement. Why isn't it if you understand that? Let we go. When we reach the questions, you see, a tautology is a statement that is always true, contradiction is a statement that is always false. The only times really apply this piece of knowledge is in some of the laws. So like when you boil it down, when you're simplifying a logical statement, some of the laws are tautologies or contradictions, so you can understand it's always false, it's always true. Zoom. So that is it. Now we go into the laws. The most important law. Now if you look at your book, whatever textbook you have, and you go into the laws in logic, you just see a whole page and it'll be like, forget that 2 marks. Forget that 2 marks. But it's not that bad. I'm going to tell you the only law to memorize is this one. Think of it like that. And this is the big boy law. This is the one that always seems to be tested. Well, what's the name of this law, people? This law deals with distribution, but it's not the distributive law. It deals with how the negation sign swings into the two of them. And also, I just memorized one thing, right? Like if this way, it had to go the next way. So I didn't write only two, but it's the same as if it was like this. This is not the distributive law. Then it will go like this. This is not the idempotent law. Oh gosh, all you need to revise. For example, if the Morgan's law, well done Patrice, if they actually this, if they actually use the name of the law, they just drop that. All you got I with them 2 marks. Make sure you revise this. So you have a square on your face? Yeah, go on. Thank you for noting that. Let me make some more admins out here. Just in case I have gone for a water break. Nice. This is the Morgan's law, and this is the one I want you all to think that you need to memorize. So you set yourself like, okay, this is the one I need to memorize. Now all the other laws you need to know them too, but you're not thinking like you need to memorize them. So you think like you need to memorize these. Now let me show you how the other laws is gonna feel like you're not forcing yourself and beating up on memorizing it, right? This, just keep in mind that this law is very, very important. And I also want you to always think of this law in terms of like a bracket is here. So when the law finishes like a bracket over these two numbers, that plays some tricks on me in the private class, in a private pure maths class, or should I say tricks on me. Absorption law, to me this law just makes sense. This is the same, one this way, one that way. If you have the P and the P there, that's there, it's just going to boil down to P. All these laws can be verified very simply with a truth table. So this doesn't feel like I need to memorize this. If somebody says, what's the absorption law? That's the P, P, and then the next thing, you understand? So next way to write is I can put P, P, Q, the two brackets there, and just make sure I have this and that the opposite way. And it will always boil down to P. Absorption law. No such a big brain power involved there. And these laws are just useful in squeezing down things. Here's a face tracking. Then, let's call this. What's the name of this? I forget what it's called. This is just, if I had to call this, I'll call this the obvious law. So tell me the name in the chat. The first thing is right. Somebody mentioned it before already. This just, and again, is not a big memorizing thing. This is like, if you have P and you have P here, 1, 0, one zero. P had to be the same, right? So 1 0 1 0. P or P will give you 1 0, and P will give you 1 0, because both of them is 1 or both of them is 0. The O and don't really get a chance to shine there. I keep using 1 and 0. T and F in them potent law, right? So this is the first thing that's normally tell you. Easy thing. Associative and commutative and distributive come into play with logic. Associative, what is associative? We talk about this at the start of the class. This is grouping. Commutative is order. Commute, direction, how you're going to work, order, which place you go first, which place you go to first, commute. So associative just means, yes, they are associative. Associative, you must have three things. And notice we have the same symbol with associative, right? So associative says if I do this first and then come out with that is the same as if I did, and I don't think this will be tested in your multiple choice, it's the same as that. Associative. Commutative says it doesn't matter the order. So like if I have this, is the same, sorry, Q, it's the same as Q and P. Once again, these are just little frivolous things, there's nothing to memorize. P or Q is the same as Q or P. You know, order, unimportant. Which one you do first? Unimportant. Once it's the same function, once it's the same operation. Why isn't the chat funny good? I'm not doing paper 3 on the 14th. I think paper 3 is on the 14th. But I will be doing paper 3 for maths soon. Nice. So just a quick recap. So far, logic breakdown. You know your negation, you know your and, you know your or. You know your truth tables for your or, your truth table for your and. How to create other truth tables, like you have, you know, a next thing to train before you come up with the final answer. You know your conditional statements. I hope I wasn't saying weird things in between. Like mixer. Lubia, Zion, get away! What are you doing, like? Yeah, where was I? And you know the three things they're always asking: contrapositive, converse, and inverse. And then biconditional. You know your tautology, you know your contradiction. We know De Morgan's. This is the important fella. Tell me if you know what song this man sing. He's singing this little light of mine. Come now, you go back inside, Papa. I'm coming back now, eh? To sing this little light of mine, then? This little light of mine, I'm gonna let it shine, let it shine, let it shine, let it shine. Say bye-bye. Bye-bye. Bye. Yes, sorry about that. So De Morgan's, the absorption, where it is two ways, it absorbs into one. This ridiculous idempotent law is idempotent, the obvious law. Associative, commutative, and distributive. Can't talk now, what's up? Alright, so distributive. How does the distributive law work? It distributes. Remember now notice this is happening on the outside, right? This is like your multiply and this is like your add. Remember distributive law, if you had like A by B plus C, we do this earlier today. This is A by B plus A by C. Remember? It's like if you have multiply here, the multiply comes here and the operation that is happening in the middle, the addition, comes back in the middle here. So the same thing works in the distributive law for this. So you'll have P and Q, and it's like you're adding, or you're putting back whatever was there, P and R. Know that. Very important things. Tell yourself important things. Write that down. Write that down. Write that down. Write important things. Right? This could be, they could figure out a way to test you on this in the multiple choice. Now if it the other way, notice it's two different things, right? If it's the other way, it will look like this. P, just the other way, right? So this is like the middle term now, and this, the or happening to the both of them. So yes, there's a case of association, there's a case of distribution, there's a case of commutation, commutativeness, right? Right, next thing. Oh, this thing just never stopped. The identities. Once again, this is another one obvious, just like the idempotent. Remember what the idempotent is again? The P and P is always P, or P is always P, because it's just ridiculous. Right. So this one, the identity, says if you is, in other words, like they're telling you what is the identity of the OR function. The identity of the OR function is false, and the identity of the true function of the AND function is true, because you do truth, you do something that's always true, and P will give you back P. Let's just see it in a truth table so it can just be a little clearer. I'm going to put you on this side over so, and once you understand it, you shouldn't have to memorize it too much. You just, you know, the bed shining. Let me just load down the filter. Because the filter hitting me that shot. But then anytime I went on a white jersey, I bet that shining on it. I bet that shining. What's about, what were you talking about, boy? What are you talking about? Oh, you from a different country. So P false will just mean you have it always false now. Like a raw contradiction comes. We don't need so much, it's just P. So one's true, false, right? So P or false, or once you see that true, remember the OR function is just look for a true to give back a true. So this is true. This is no true here, so this is false. So P or false is P. This is a P. That is P back again. So P or false is P. You understand? Why is it each other? You understand how that works? You can verify all of these that same way. How about P and false? And false. There's no double T's here. So it means since there are no double T's, I can't get no truths. Everything just here false. So P and false would be false. Just a straight false. Just a straight contradiction. This is logic. Similarly, same way, same how, if it was just all truths here, and this is a true instead, what would be the result if we had P and true? P and true. P and true would be true and true. So we have a double T here, so we can say, hey, true boy, and no double T's here. So remember, and you need two T's to give back a T. So this is false. So P and T is P. P and T is P. What about or? How are we going to get true? Or? P or? Well, there's a T here, so it's true, because or once there's one T, it's true. And there's a T here, so it's true. So P or T is true. So these are the 4 identities that I want to know. So down in, just check it through, drop the truth table, feel comfortable with it. You can always figure it back out in the exam. Really and truly, you're just memorizing de Morgan's law, which is an easy thing to memorize. When you drop that negate sign outside the brackets, is flip everything. Well, let me just make sure we have it. Negate P, let me see what's an and here, Q. Alright, both of them will get wet down. Both of them get wet down like that with the negation. But they go flip. Whoever was here, flip. The Morgans. Ting! So this is like a weird kind of distribution, distributing that negation sign. Alright, I think we're ready for some more questions in. Oh, complement. Let me see if you have anything more. Alright, complement. This is the same thing, verify. So if you have P and you have not P, so this is like ones, I keep using one. T, F, T, not P will be F, T, right? The other way around. So if we have or, then it's true, because you have or, you have a true happening. If you have, let me just bring you across here, my brother. If you have and, well, it's false because they don't have any double T's. That's a false. So that rule is called the complement. So I guess just understand the rules, try and learn off the names, complement, idempotent, de Morgan's, distributive, associative, commutative. What else we have? Identity, absorption. Understand it, make sure you can spot it in a question to help you break down stuff. Alright. So what about this law here? What's the answer for this one? We back to questions now. I could raise up the filter while I you're answering this question. This could go a little stronger. Nice. Clean and clear. So you do intimate too? Well, intimate of course, but if you're watching this, well, this part is not integrated maths, but when I started doing logs and indices today, because I'm doing all of module 1 today and some is overlapping integrated maths. So what you want to do is skim through and find what you do. Hey bro, your mic sucks. Alright. Glad I'm not doing this till 2024, but it's still coming. Never mind. A. B, A. So A. Mostly is this looking a little Morganish. So it would be equal to this. But if you're watching the answers, you're not seeing anything like that. So don't get tied up and force any one of these to work. Because it's supposed to flip. So this is a faker. And look out for the fakers. So all you need to do is just remove them brackets. And yes, you can't do that. You can't just say not P and not Q. We don't need those brackets. This not already indicates that it's tied to that. That's like saying 3 squared plus 4 squared. We just remove the brackets. It's still okay. It's still fine. So the answer is A. Next one. Oh gosh. I need to parallel next person in hidden land. For the private candidate, you didn't get through the exam slips for CSEC to use the computer and get it downloaded. This is how I obtained. Alright, cool. I hope I didn't hide the wrong person. This class will go on as long as we need to. Let me get some answers here. So all these people are just spamming. Yeah. Yeah. A, B, B, D, D. Alright, you study. So with this question, we need to identify what but really means. What does but really mean? But is or and. That's what you need to ask yourself. And once you memorize that, you're ready for this question. Because you did not study and did not plan. And. So not study, not plan. Study, plan, pass. Cool. So not study and not study and not plan. Not study and not plan. So it's either B or D. It's either B or D. But it's but an and statement or an or statement. It's but an and statement. Think about this. If I say I'm hungry, but I'm going to sleep. I'm going to sleep. So one of the questions that test you in CAPE is if you know what but means. That's it. I'm hungry, but I'm going to sleep. Is that like an or an and? Can I say I'm going to sleep and I'm hungry? Or can I say I'm going to sleep or I'm hungry? Which one makes sense? I'm going to sleep and I'm hungry, or I'm hungry and I'm going to sleep, or I'm hungry or I'm going to sleep. From there you can clearly see that or making no sense, or not carrying the same idea as this is happening but I'm still going to do this, but this is also happening and this is also happening. So but is an and. But is and. The only reason we sometimes use but is to contrast the two, like this is so weird and I'm still going to do this. So you put but. You know? I don't like how this person is look, but I still love them. I'm still going to be in a relationship with them. Alright? So but is like a contrast. So but is and. Remember that. So therefore it's not going to be B, it's going to be D. Once you have it, you have it. Anytime you see that but thing, they come in to test you with that as well. So that's it, what this question is testing you about. So it's how I didn't put the answers for this question, but I have it written down here somewhere. P implies not Q. Not P implies not Q. P and not Q. Not P and Q. It needs some answers there, people. CSEC gonna treat us badly, people, and I think it's 9C. 9C? Yeah. I feel it's 9C. Which country you belong to? I'm from Trinidad in the Caribbean. It's actually one of the best, if not the best, country in the world. This is an accepted fact. So I'm waiting for some answers. Now this question, I think I did this in a public live or something some time ago, or in a crash course, and I left out one thing. And then I corrected it in the private class or something like that. Shania, remember this question? Patrice, anybody here? Alright, so let me break it down. I already started. You have the not P or thing. This is the question, right? This is the question here. And we know the Morgan's law. So that's the first law we're going to use to jump out. We self. Boom. Somebody saying D. First law we're going to use to jump out is the Morgan's law. It switch. Good. Everything looking good here, man. So I did this correct. So you put the negation outside here. And then the next thing people do is jump out with this here. So wow. So cool. And then next thing you're looking to do is maybe one of these eradicate, or one of these eradicate, something like that. So I'm going to go down a dark road here, which is not the way, but just showing you. So you will say not P and P. That was false. Not P and P. True, false, false, true. No double T's, so that just false all the way. So this is false and or not Q, and it's starting to look real off, or not Q. So this is really Q, false or not Q, false or not Q. So let's say this was, let's say it's TF now. So you really don't know what happened at the end of the day here. So it's kind of weird. Or you may try to eliminate this one. You may try to eliminate this one. No, because it's P and Q. And the P's disappear, and in the answers, none of the P's disappeared. So what really going on here? This is the thing I want you all to remember. This the Morgan's law, when you have this on the outside going into the brackets here, it's like if there's an imaginary big brackets around this. You still need to do all of this first. In other words, this is like if you had a bracket of x plus 2 squared. You need to deal with that whole contraption here first. So it means that this is still locked up in itself. That changes the whole statement. That them two brackets change the whole statement there. Cassidy, what's up? Yup, yeah, we did that crash course thing. So you can use some keep thing. So them brackets change the whole statement there. So just don't forget them brackets, right? Please. And not P and this, we know this. What is this? What law are we going to activate here? What law are we going to stunt on them here, people? I don't know why I write back the same thing. This is the same thing as that. What law? What law when I come out here? Tell me the law. Which logic law we going to use here? Not the associative, not the commutative. You are going to use the distributive law. This is distributing using this and function across and not across or. Across the or. I'm using the word function kind of loosely here. So we know this, and you put back this or, and then you say this by that, right? So this P, is that there all the time? Yeah. Or not Q. Did I have the answer? Not P or not Q. Not P. I didn't write the answer in. Yeah. So I left out that. Let's see the mistake there. So the distributive law. So, alright, this distributes here and this distributes there. So you have not P and P, not P and not Q. But this O comes back down there. And we know that this will go to false. False or this. I think this is like the hardest question probably in the paper that could come. So just make sure that when we do this, that you memorize this, you understand this, you could go through this whole thing by yourself, go and check out other questions similar to this where you use this negation sign on the outside here. So you'll know this last two steps. From here easy, this will boil down to F. F, false or anything will always be the thing. False or P is P. P or false is P. So false or this big thing here will just be the big thing there. So the answer is D, but I did leave out that symbol in the beginning. Why is in the chat if you understand that? If you have any specific questions, ask. Yeah, so if keeping up with CSEC standards, this is really a paper 2 question. But I've seen long things like this come in the paper 1. Because you see, you have like you're being tested on too many things here now. From the time you do one step, it's gone out of the paper 1 mark per question thing. This is like in a paper 2, this question will go for 2 or 3 marks. For sure, not a 1. This is now a 1 mark question. Alright, so that's enough of that. Let's go forward. Rationalize. Easy thing. Can you go over the second line? So it started off with not P. Started off with this. Let's just copy this. I'm going to just speak through the whole thing again because I was a little scrappy there anytime the teacher sticks somewhere, people has lost knowledge. People is getting frightened. Alright, so this not P or not, this will switch. So I'll turn this around like this, whap, because that's what this sign does. When you're distributing, that not sign, that negate sign, it flips the one in the brackets. So that's going from an O to an. And it's like this, it's this rule. Not A and B is the same as not A or not B. So this whole thing is just like one term. We're just treating it as one term for now. Boom. Not P and Q. We have to do the same thing again. Keep it in a bracket. So this is like P or not Q. Did I say that? P or not Q? I left out a little over here. When you have a double negative, it goes back to like the positive, right? So like the double negation here, negate by that. This is like this, that is like just P by himself. think there's a law too, but all these laws and things, forget that. And now, distributive law, so this P and E, or this P, not P and not Q. This is false or not P and not Q. See how much steps it take? It take one too many steps here. That last step throw it into another paper too. So false or anything will just give you the thing. So this is the answer in the end here. I see people keeping on busy, but who's this person? I'm gonna just hide them on the thing one time. I use on this channel. Alright people, we gotta go forward. Answers for number 10. So can you do some Cape Unit 1 physics, please? I'll try. I'm not doing anything Unit 2. I don't think I'll reach to Unit 2, unfortunately. I hope this is not making too much noise for me dragging the camera over the place. See, somebody says, see, there's a calculator question, straight out of Hampton, straight out of Compton, straight up calculator question. What are you doing on here? Right. On. Mode 1, fraction 1 plus 2, I'll show you how to do the other way, square root 2, denominator now, square root 2 minus, now you notice something happening there, that you see what's going on there, that square root sign following me, so I need to come out of that square root sign, go forward, minus 2. This is what I get. I need to see what looks similar to this. C is indeed the answer because I'm getting negative 6 plus 5 on the square root of 2, all divided by 2. So it means that this would be divided by 2 and this will be divided by 2. Or calculator blocking. This will be divided by 2 and this will be divided by 2. Initially you're getting all divided by 2. So this is negative 3 plus 5. Y'all catch this. The way to do this is rationalizing the denominator. The way to do this is getting rid of this by multiplying by the conjugate. So you have square root 2 minus 2 multiplied by square root 2 plus 2 on the denominator. But if you do it on the denominator, you have to do it up top as well. Square root 2 plus 2, multiply out that, and you would arrive at the same answer that your calculator gives. Anybody need any further help in this? Bearing in mind, if you multiply by a square root 2 by square root 2, you're going to get 2. That's why that's how it ends up rationalizing. And because you have the conjugate, the middle term will disappear. Somebody said A. Yikes. Don't forget to divide the second term by 2 as well. Okay, so this one is a little more troublesome because you can't just plug it straight into your calculator. Your calculator not made this to crunch variables like that to give you a variable answer. That will be programmable. So hit me some answers. What are we going to do? Oh, some people had some problems. Anybody had problems with number 10? If you had problems with number 10, say where you got any problem. Watch it and tell me where you get the problem. So number 11 now. Answers for number 11. 144 people. We climb in. 10:54 already. How long is like 1 hour and 47 minutes? Wow, I just feeling like an hour. Woo, you getting people in this pure maths thing, boy. I wonder if because I have to do with hacking in this title. Doing the question now. Question taking a while. It will be some answers here. Once again, you could weasel out some of the work here with your calculator. And as I said, in the red, I write in all shortcuts here. Like if you really don't understand search and don't know what to do here, a trick you can do is just substitute a random number for x. Substitute a random number for x. So let me show you what I mean. What do I mean by that? So let's say I say x is 10. I just let x be 10. So I'm going to put 10 there, put 10 there, and put 10 here, put 10 there, and see which one equates. That's hacking the question. So for example, it's not that hard to do. Most questions have, as I said, the harder the maths gets, the easier it is to kind of come up with a way to weasel the question. 2 by the square root of 10 plus 2 by the square root of 50, because 5 by 10, right? 50 divided by the square root of, 50. So your calculator give you that, or if you had a calculator that give you it like this. Cool. 2 plus 2 root 10. 2 plus 2 root 10. So now we just need to check and see if 5 by the square root of 10. Nah, that one ain't working. Is that one working? You might need to check through all. 2, let's check the D. 2 by the square root of 10 plus square root of 10 over 5. I find none in working. 3 by the square root of 10. Was this the same answer we get before? I'm going to do it the proper way just now. 2 by the square root of 10 plus 10 squared. Did I make a mistake in this question? This one definitely not the answer. Let me see. Square root of 10, 50. With all these sales questions you're looking with Cape, they always bring in where all these spammers coming from, by high user on this channel. They're always looking for square roots. So like if you're square root of 50, 25 by 2. So you have 2 root x plus this question. I did this question last night. I made up this question last night. 2 square root of 2 times 25. So this is 2 root x plus 2 square root of 5x. This question does not answer on anything. I made a mistake. Square root of 2 by 5. I wanted this to cancel with that, but I made a mistake. Only understand what happened there? Answer is E. Like, if this had cancelled, it would have given me 2x and x is 3x. So let me just switch this around to make this work. Lord Father. Alright, square root of 2 root 2. Take this 2 here. take this 5, put that there, take this 2 here, put that there. Try it again. All line it up here. 2 root 10. So once again I'm using the substitution method. I don't know, I feel as how I have factored in the normally you get people from India, but it's normally get respectful people who try to learn. But again, once that's spammers from India right now. 2 by 10 is 20 divided by root 50. The root of 50. And in other words, a substitution need 10 here, 3 root 10, right? So immediately that tells me that this is the answer. To me, this method actually works faster. What do you think? Why is in the chat if you all understand this method? CSEC normally brings a question like this, where something here will cancel with something there. You need to use some surds to get it and it will cancel. Or even it can be linear, and you use surds cancel out and then you add up all and you get one of these answers. You rarely get like a double of an answer like that. So what I'm saying is you don't even need to understand surds. You could just substitute a value, some random value, 10. You could say let x be 10 and work that out in the calculator and see which one here lines up to 3 by the square root of 10. That's what I did. It's on the screen here. I substitute x is equal to 10 and 2 by 10 here, which is 20. Press equal and answers 3 by the square root of 10. Now what's the way to actually do this is you'll have 2 root x plus 5 by root 2 by x over, instead of square root of 50, we'll have square root of, I just did it right, 2 times 25. So this is going to be 2 root x plus 5 square root of 2. Square root of 2x is the same as square root of 2 by square root of x. And this is square root of 2. Square root of 25 is 5. So this is like square root of 2 times 5. Or another way to write this is 5 square root of 2. When this cancels with that, you're going to just end up straight up with 3 root x. Because this is like 2 apples plus 1 apple is 3 apples. So this is the surds way of doing it. Yes, exactly, Gavin. And this is the working out way of doing it. For each question in pure maths, I would say like 95% of the question, there are 2 or 3 ways of doing the question. One of them is almost always some kind of substitution. You substitute a random number and see if it works out. Always pick your numbers wisely though. There is the case where you substitute a random number and it works out in more than 1 or something. But the chances of that happening is very rare. What's the simplest form of correct? You from last year. What's the simplest form of this? Yeah, Maya. So just do the other method. Some loss. Could you change the numerator to 50x? That making sense to me. I don't know why I would want to do that. Once again, oh God, logs again. Once again, you can replace, you don't even need to understand logs. You can replace Q with a random number. A good number in these exams is always 10. Right? Sometimes you don't want to use 1 and 0 and 2 and thing. You want to use that number with some weight, but an easy number to deal with. So you replace this with 10, get your answer on your calculator, whatever it is. Once your calculator can do bases, otherwise you'll need to know how to do the change of base little trick. and then check this out, put in 10 here, and see which one work out to give you the answer. This is a 9 here, people. See which one work out to give you the answer. Some people saying B, some people saying C. Tahila saying B. Zachary C. Luminous saying C. Conroy B. Shaquin C. You have a B and C battle here. Yeah, I feel like I didn't want it to be C. So I think the B people cooking with that C, as they say. Ramco gas. Alright, so which method do I want me to do first, boy? I want to show you hack method first. I will just show that method first. Hacking the question. Press on your calculator. Reset the thing. 3. Now if you're doing log to base 2, you need to press this one and indicate what base you're using. Some calculators don't have that function, so you need to know how to do change of base. I have a video on that, just look up logs. 2 log 2. Remember it's in QB 10 now, so that's why that's number 3 by 10 is 30 plus 1. So from this I'm seeing that the answer is 4.152. Just write that down somewhere. And now we come in the answers, we go in and check and see which answer is going to hit me that. Shania, you got a nice method here to double check in case you're feeling so confident. So remember I let Q be equal to 10. So when I see 8Q, I'm going to put 80 over 9. That is not 4.152. Check the next one. Log to the base 2 of 16 over, no, it's 160 because Q right there over 9. 4.152, the answer is B. So we substituted, we hacked the question, we come up with the own little number and throw it into the question, get a number for it, and then try out that same number with the answers. I don't know if you're understanding how incredible that is. So you can bypass actually learning what logs is there. Bypass the rules of logs. But let's go through how to actually do this. There's a 3 here, so this is supposed to come up on top. So this is log 2, and I would still advise to use that method to double check your answers when you're coming back around the second time. Log 2 3q squared plus 1. So you see how that's the power rule, right? Power rule, send it up. Then this is subtract, so you need to divide. Logs, right? Log A minus log B is log A over B. So this is log to the base 2. We always deal with that same base that they give us. Must be the same basis for it to occur. 2q 3q squared plus 1. You see that plus 1? You see how we see in plus 1 here? Simplest form. C is an answer, but it's not the simplest form. You want the best answer. This could simplify some more. How do you see? In this case, when you come here now and you check this out with your 10, you would get the same 4.152, you know. But you know that this is looking simpler than that, so you know this is the answer. But how are we getting rid of this 1? This is the trick with logs. You can say log to the base 2 of 2 is the same as 1. So you're hitting the same base and you just put the number there. And now we can do some more gymnastics again. But before we do them gymnastics, let's get rid of this. You see this is q squared and this is q cube here. So this is actually log to the base 2q on 3 plus log to the base 2 of 2. Hey, I supposed to cube this whole thing. Back it up. I supposed to cube this whole thing. Let's see what I mean, right? This cube went up here. As a mistake, I sure they probably had an answer waiting for them. Maybe answers waiting for us there. So you're supposed to cube that and square that. So this whole thing to be cubed, this whole thing to be squared. So yeah, definitely come and simplify this now. Log to the base 2, 8, because 2 cubed is 8, q cubed, 9 q squared. This will cancel with 2 of that and just leave me with a q on the top. So q over 9 plus, why is in the chat if you understand all of that? Then group it together. So the substitution method beat out this method here. Actually, you may have done this fast too in the exam. You would be oiled up, so you'll be going through this question. Wait, where these people coming from? Where these people coming from? Look at one star people coming from. Put user in time, what high user on this channel? High user on this channel. So yo, what we doing now? We just had to divide by 2. We just had to divide, we had to multiply as addition. So 16q 9. Yeah. Base 2b. So this is the working it out way. You have the hack method that I show you. Feel free to get right. Population growth in an island is modeled as f of x is equal to 2x. I know they do something like this where fx is the growth in 1,000 for years, x years. How many years for the population growth to reach 64,000? A few things in this question. When they bring in this question, I think some of the answers is be logs, and I show people also they be thinking logs. What to do in logs, right? What to do in logs? I say that index is more of an indices question. Next thing is they say growth in thousands here, right? So you can really think of that as 64 really. F of x the growth in thousands for years. How many years for the population growth to 64,000 in thousands? So this is how many years for 64 to be equal to 2x. X is the years, right? X is years. 2 to what power is 64? That's all basically asking you. 2 to what power gives you 64? Two to what power gives you 64? Very well. Yes. So that's 64 there, real tempting to pop out. It's 2 to what power gives you 64? 2 to the power 6 is equal to 2 to the power x. In this case, 2 to the power 6 is 64. So just 6 is equal to x. X is equal to 6. 2 to the power 5 is 32. 2 to the power 6 is easy thing. Next question. This is straight up calculator. It has no x in this, it has no p, it has no q, it has no anything in this. You can just jump out with your calculator now. Now there's a way to work this. Once again, there's a way to work through this. You always see that 36 there. Square root 36, 25. There's a way to work it. And I'd advise you doing both methods. But for now, just rough out your calculator and laugh at them. Laugh off at them again. Ha ha ha. And you bring out your calculator and you say, yo, half, well it's normal logs, so great. Natural logs. Log 36, and the thing with this calculator, you're just crunching through anything that track, you're crunching it through very quickly and in a nice natural math format, right? Log 15. You see some of the answers in log, so we may have to use the calculator to just whip it out. I'll show you how to do the other method. The other method may be quicker for some people. So you get 0.176. Let's double check that I ain't doing nothing crazy. So 0.176. This answer is out. So now we see in like if the log of 3 and 2 is that. Boom. First answer. Well, second answer. B. Why is any chance if you understand that? I'm just showing you. Don't frighten in your pure maths exam. Don't be too afraid. Question to be new like new. The question can be new. A lot of these questions, logs, a lot of these questions you can use substitution, you can use other methods to try and just weasel your way out of the question or verify your answer if you're feeling a little shaky about it. This question is testing some laws of logs here again. So what you'll do is bring up that half. And you know that fractional power indicates roots. So the power of a half indicates that we want to get the square root of that. So there, log 15 minus log 12. So log of 6 over 5, square root, right? Plus log of 15. If we add in on, by the way, have a little bit about math playing off in some of these questions sometimes. So we have to do the addition first. Like if the addition is here, you do that first. If multiplication, pay attention to that. I have one answer because of commutative law. I could have two different answers sometimes. So, but in this case, I think you're getting the same thing both ways. This one you'll end up multiplying. This you'll end up dividing the final answer because it's subtract, right? So it's like 6 by 15. So it's like log of 6 by 15 over 5 by 12. It's already working on so nice, man. So yeah, 2, 3 or 2. Nice thing. You get 90 over 60, which is the same. Nice. Gavin doing the thing. Next question. So you all understand the two methods to crack that question, the way that they want you to do it and the way that you could use it with just plugging it in your calculator. Which are the following are factors. Remember what I said about pure maths, context. They try to remove the context. So sometimes you're doing one question, bam, you come back to this. You come back to the next topic. They don't put the topics. There's a general order, but in the modules, sometimes you can have some cross-pollination. Just so that you can lose context. Alright, which of the following factors? Boy, I make up the question when I was real sleepy, you know. I can't remember which one I wanted it to be factors. Ting, 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 ting. So this is the next style of factor term that can be asked. I'm just waiting on the answers here. How long we run in this life? 2 hours and 10 minutes. We taking time. Here comes the C. Yeah, I feel like that 2 hours fly. Now you see the next 2 hours will fly like that. Or next 10 hours, however long we stay on this module. Which of the following are factors of that some ridiculously long thing is a substitute. So you substitute negative, everybody can see? You substitute negative 2 in that, see? Yeah, I think that's what I wanted. And negative 4, negative 3, positive 3. So negative 2 and positive 3. We do a little input thing and yeah, easy, right? We do this already. Which is not a function. Oh my gosh, which is not a function yet. Pay attention to what they're asking you. We'll also ask on this easy question. Vertical line test. It's not supposed to touch two things at the same time. That is not a function. Either that they will bring, or they'll bring you one like this, or they'll bring you one like this. And you know, or sometimes they'll ask you which one is a function, and it only have one of them inside it. That making sense? I don't know why they ask this question to pure math students. This is probably a take a free markist. Take a mark there, my brother. Alright, this is a little more respectable. Let's get the answer for 17. A lot of people get this wrong for some reason. I think I posted a question like this on Instagram at time. I like how Shouldn't I just thinking out people black is white here? Anybody on your timeout, I just hiding them one time now. So Nafisa says D. Alison Alexander says D. Her name sounds familiar, very familiar. Sharida Brathwaite says D. Zachary says C. Richard says C as well. Patrice coming in with D. Alright, so the one that's closest to the number is the one that you do first, so f of 3. F of 3 means x is 3, and you're substituting that into the function. Right, so 3, x is 3, so what happens? X is 3. That's the input. X is the input, f of x is the output. 3 is the input, f of x is the output. So we have 1. So we hold in 1 now. So I can erase this and put 1. Hey, I do this question properly. G inverse of 1. G inverse, so I decided to put inverse there, but alright. G inverse of 1. So G inverse means backwards. So you're not going to say 1 is a third and come with, I think you have a third there. You need to go back. So you need to start from the G of x side and figure out what is the x side. So we starting off with the 1, right? But not here. A third would be a good answer, a good distractor to put in there. But 1, and you're going to come in here now, and the new answer would be 5. That's how that question is work. Well done, Gavin. So look out for this inverse, that tricky little inverse sign there, tricky. So you need to know the order in this question. This question is testing your memory. And nothing to hack in this question is an easy question, is a 2-second question if you understand what's going on. If so much. The time on this question is the time taking to shade the answer. But you need to understand what's going on. Which of the following graphs represent the inverse of that graph here in this corner here? What is the inverse? It's testing one thing and one thing alone. Boy! Nice. Aaron, you know reach by? If you're not important thing you miss it by Aaron. I feel like this, if I was a student, unit 1, this video would have been the ideal video for me. Right? After your study, right before exam, you know. So weeks before exam, you go through the whole unit module 1. I'd be asking in comments, make sure I know module 2, please. Module 3, together. Is the best. Reflecting the line y equal to x, easy thing again, so B is the best answer. There's one case, one scenario that can happen. Like if instead of this, I drew this graph here. The inverse of that function is the function. I'll go and see the box around me again, because it lost focus. The inverse of this function is the same thing. Reflection will be the same thing. So A would have to be the answer for in this case. But the earlier case, B was the answer. Next question. Remember this? I want correct answers, please. I don't understand the inverse one. Shanique Bennett, are you in pure maths? I just want to make sure you're doing pure maths unit 1 for keep lower 6. Not that saying anything, but normally I lower 6 student would I mean, once you go in your classes, you might have catch that one. But if you catch that, I'll be too bad. But I'm just thinking maybe you're from CSEC or AdMaths or something. What is the contrapositive? Number 19. 19C. If he studies contrapositive, so you need to swap and negate. So I just looking for studies well past. Pass come in front with the not right. Way to go. C. Oh, you're doing pure maths, so C. So I think it's this inverse one you're talking about. Remember, input, output, x, f of x. So initially is f of 3 inside there. So input is 3, f of x is output. This is the input, this is the output. Put in 3, get 1. You ain't done yet. Have a g on the outside here. But when you have inverse, all of a sudden, this is the input now. This is the output. So it's like you're doing the same thing twice. But just pay attention to the inverse. It flips the input and the output. So, what's the last number we had? 1? 1. So, 1 is the new input because 1 is coming here. 1 needs to go in the input, so we need to find where 1 is in the input and the output is 5. That's it, the answer is 5. Can we get answer for number 20 now? Alright, so I think we need to teach this lesson. We cracked you a lot of things. Inverse of the converse is the contrapositive. Or whatever floats your boat, Gavin. Whatever floats your boat. So this question usually comes two kind of ways, like this way where it's just like 5 and 5 here and you just multiply everything by 5 to get the integral form. Or sometimes you could have 2, they might have 3 and like 8 here. So you'll have to find the LCM of 3 and 8 and multiply up and you will end up with what, 24. So everything will get hit by 24. But you should know where the alpha goes, where the beta goes, where the gamma goes. B, people say B. B is correct. B is correct. So just to recap this very quickly, you're saying that alpha is a root, beta is a root, and including gamma now. So the factors here will be like x minus alpha, x plus x minus beta, x minus gamma. If you multiply all this, I'm not really feeling to do that. If you multiply all this, you realize you'll get x cubed. You'll end up with the sum of the roots here. In terms of negative, you'll have negative alpha, negative beta, x squared, negative, so you'll end up with the sum of the roots, x squared. Over here now, you'll end up with this, the product of the roots 2 at a time, the sum of the product of the roots 2 at a time. But it's going to be negative here, so it's going to be positive here. So alpha, anyhow you want to do this, just make sure everybody get hit with everybody. Alpha, beta, beta, gamma, and alpha need to hit gamma now, alpha, gamma. Right? X. And the last but not least, you just end up with straight up the product of the roots, where it will be negative. So once you know that, you're good. Also, they could swing back on you and just bring the alpha and beta. Instead of training the gamma, they bring the alpha and beta just so. You can just bring the alpha and beta. The alpha and beta is simple. You start with the negative sum. So like if it was just a quadratic, this is for cubic. A cubic polynomial. If it was just a quadratic, it would be like alpha and beta alone are the 2 roots. So x minus alpha, x minus beta. In the end, you'll end up with x squared minus alpha plus beta x plus alpha beta. So it's minus the sum plus the product. Straight up. This one's straightforward. Easier. Easy thing. This is a maths. This is what you do to get into pure maths right now. But top one is how we're dealing with in this question. So we look in it in order. They give us it in order. So this is the first thing. This is the second thing. This is the third thing. It can't get easier than that. Pay attention to the signs. Negative, negative. This just testing this to see if you remember which sign comes where. negative, negative, negative. So this one, the first one will switch and the last one will switch, because negative and a negative will make it back positive, and this will remain as is. So that's all you needed to do to check the answer. You didn't need to know what you're multiplying by and anything like that. But the reason the 5 come here is because they multiply the whole equation by 5 in the end. Next question. Alright, so if they bring in proofs, they'll bring like a silly little proof like this. The thing with proofs, you could always just verify, because the answer here, proofs only come as a hard question when you don't know what the answer is. But like if you have proofs and you have the answers live in the multiple choice somewhere, in the multiple choice answers, you could just watch the answers and gauge it using the hacking method. Just like using random numbers now, to see which one works out to give you the answer. Brianna Mandel, what you don't get about it? Sum of pairwise products. So which one is true? If x and y is a negative integer and x is greater than y, x squared is less than y squared. X is greater than y. X squared is less than y squared. That's interesting. That's interesting. X squared is more than y squared. I mean, like in that. X minus negative x is more. Once again, for this I really advise you to just substitute the numbers, because that's what I do in my mind, and I figure out the answer kind of quick. So you're using the kind of trial and error method. But this is some kind of law. Indeed, the answer is E. You don't get how I get the answer for this one? Minus is ax cubed minus sum of roots x squared plus sum of product 2 at a time, or pairwise product x plus just the product. Let me make myself here. No, not plus the product, subtract the product. So all the testing is to see the sign negative, positive, negative. So I choose positive, negative, positive because all the answers here were negative to begin with. So I just invert the sign. You could actually go and substitute it into the equation, multiply by 5, see it work out for yourself, but I mean, save time now, man. Why people saying B for this one? So, alright, x is greater than y, right? So is negative. You trick that. So like x is like negative 2 and y is like negative 3. X there is greater than y. Negative 2 is higher than negative 3 in the number line. But if I square that, all of a sudden the negative 3 will start to shine. It will go 3. I'm sorry, 9 and 4. So 9 is greater than 4 now. So if x started off higher than y, x started off higher than y, then x is going to end up x squared. You understand what I'm saying? X squared is going to suffer around x squared is going to end up lower now. You're going to lose order. Why is in the chat if you understand? Allez with me. I feel we finishing. I feel we finishing in 3 hours based on how much questions you have again. I don't think you have much to do again. You have the summation. I didn't do much summation questions, partly because I have a whole long 1 hour video on summation, everything you need to do. Well, more on induction, but it covers summation as well. Well, it should be safe there, man. An next easy question, you can actually literally just put this in your calculator and get the answer. I don't know where it is with these kind of questions. Now there's a way, I'll show you the way to do it on your calculator. Log square root of 5, 25 Anytime they get a question with just numbers and logs, just pay loud, loud. So you see the answer there. How would you do this otherwise? Well, you're trying to say that it's equal to something, so I'm just going to say A. Log square root of 525 is equal to A. Convert this to exponent form, if you will. I say 25 and 22, I really shut it down here. 25 is equal to square root of 5 to the power B. You should know how to do this, eh? I also have a whole video on logs. Showing you how to do this. If you didn't, please go and watch the video on. Let me just show you it so you know you feel it in your system. Logs, Irwin Springer. Add math logs and graphs. Logarithm, pure maths logs, indices and search. Stream 8 months ago. You could watch that. You could, a real thing out here looks. I want to find the specific one I want you all to do. It kind of recent. So some light revision. Watch that video. Watch that one there, yeah. Ads, boy. Who go for ads and a learning video, boy? Who will do such a thing?
So that's the first point. Right here, so that's it from the X.
Well, I don't want to find this. I delete it all. I give myself 2 more minutes to try and find this. I'll drink some water. Good thing I went and looked for it, otherwise I never find it. It's a real log video here, but I want to find the one where I just do everything.
Alright, so we live not now on then. I need some help. Are you good? Which one? Gonna be.
This is one as well. If you're in focus without Casios. Now the sharp can do, some of the sharps can do a lot of the same functions. It's just a little harder to do. Like I have some videos showing you how to get the best out of the sharp. Watch this. You could watch it on 1.5 speed, you know. Your time is the most important thing out here to you. Earlier I know I do a sweet pure maths video on the whole logs. If I find it, I'll post it on Instagram. What somebody asking me, I don't know. Log 25 divided by the log square root of 5 could work 2. Wait, you're trying to change base or something? Yeah. Yes. Alright, let me bring it home. Ding 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 ding. So this is what I usually ask in them. It's called a series. This is the kind of questions they usually ask. You should know. They will ask you pertaining to the rules of summation. The sigma rules. Like Can you take the square and carry it over there like logs? Don't be mad, eh? You cannot do. Don't be mad. Don't be ridiculous. No. No. Can you say like, all right, let me do the whole thing square now? No. Can't do that. But we can play lots of games with this. That's why the games usually come about. Or we can get the general solution for that. That's where the answers usually come about as well. So let's get some answers to number 23. People really went on the water break there, boy. Make sure and post this, a big man. Aaron. I don't know why the men do just sit down and take it in the first time. I like to watch it. I like to watch it when it's still. I like to watch it after the video, just sit down and watch it. I would have liked to be in it live. Oh, Jared, what is he saying? Somebody say 23C, yes. Because if I leave out the term where R is 1, 1 squared is 1, so R squared. Yo, it's interesting. 1. R is 1 thing, R is 0. I think I write this question wrong. This wasn't what I meant to do. R is equal to, what was 0 to 1. I think I messed up this question. So I might not be here for the entire thing that's asking you to post it. Alright, cool. Yeah, I'll always post it. What I wanted to do in this question, 1 to n, backtrack 1, 0 to n. Maybe I have to do 2 to n, backtrack 1, 1 to n. Yeah, maybe it was that one to do. Yeah. Best answer in this situation here would be, I would go with C. John Paul, you're thinking the same thing I was thinking. Or if I had something like this, so R is 1 to n. So if I decide to go with 2 to n, I forgot the 1, so I need to add back in the 1. Well, it's actually 1 squared, but 1 squared is 1. So in this case, like that, I would go with D. Understand? I kind of mess up the question that I was aiming for here. This can also work using the calculator. Yes, it can. Substitute like a value for this and use your summation here. Have a summation shift sum. X is like 1, 2. So we get n a value, get n5. And put x here. Shift alpha x squared. 55. Now if I put, why is it chat if you all understanding what I'm doing? If I put 0 here, C, that problems. But if I put 2 here, hey, I get the 54 plus 1. So the question could come, it could come a few ways, like maybe they could put this here instead. Just understand what we know the limits there. And that you can't interfere with this. You can't, especially that you don't go and put the wrong answer. You can't interfere with like squaring it up or bringing down the 2, that is lots. But if you play around with this, like if I had sum of x to 2 to, let me say n, r squared, and I say what is that the same as? That is the same as like, if I use the 1 and I go to r squared, I just need to take back all the 1 this time. Right? Why isn't he chatting for the good? Why isn't he chatting for the good? I feel like I explained it a little disjointed, but it still come true. Because I messed up the question, what I wanted to say. Boom. Some more alpha beta, easier one. Can you do this? Hey, this is the meme, right? Meme here. This is like one of the most meme things in mathematics. Because alpha plus beta squared is not the same as the sum squared. You always need to what you need to remember in this case. What you need to remember. Yeah, so like the first time I come on YouTube and I was talking about Sharp and Casio calculators and things like that, people are like, oh my gosh, this, but then I say yes, this is the same calculators all the students always had. They just didn't know that you could use these features. They just didn't know how to use the calculator to the fullest. And people were worried and like, but now that you should not use it to the fullest, CSEC might say, forget these calculators. Forget these calculators now. But no, they haven't, because in a way they're not testing they're not testing you to do things that the calculator could do. They're testing you to do things that the calculator can't do. That's what the test is about. Minus 2 alpha beta, right? So minus 2 alpha beta. So this answer is B. Everybody getting B. So alpha plus beta squared, that's that. Hey, it's squared, so you need to worry about the negative sign. So is equal to negative A squared minus 2 alpha beta. Product is B. B minus 2B. So is A minus 2B. A squared, sorry, minus 2B is B. Yep. So don't forget it's minus. Now, the next thing a few students do, and I had this problem when they add maths marathon that I do the other day. If they just come now and give you alpha plus beta squared, you don't need to do anything. Just get the sum and square it. Some people so trained to subtract, they subtracting right through. They know what they're subtracting for, they're always subtracting. So if they give you alpha plus beta to be squared, cool, then the answer is just straight up a squared. The sum squared. You don't need to subtract anything. You understand? Domain and range is something that's always tested. They do all kind of silliness with this. One thing that I didn't do, that I didn't question, that I didn't bring, that I think, I can't even talk properly right now. I think I did bring the question for the crash course. How, when you have like a composite function, the domain becomes the range, and now the new range becomes the domain. Now we did something like that with the function, with the, remember the G inverse f of 3? We did something like that. Still confusing? What you confused about? Only for the confused, you need to say what you're confused about. Sometimes I go on to the next question. I say which line, so what going on with that line, what thing, about the other. Asking questions. Everybody say E for this one. Cube minus 1. Cube minus 1. 9, 9. This one is cool, but this one indicates that it's continuous. And it seems here that everything is discrete, meaning one by one, unique. So we need to get them back in this format, where each thing maps, each member of the domain maps a new to the range member. So don't go and do this one. Everybody get a practice. 26. I think I have one more question on it, one or two more questions. So we finish with an hour to spare. Not bad. Maybe I can do the 2 modules in one next time. Like it will take me 4 or 5 hours. Tricks is always take a whole while to teach. Oh, when I was explaining the calculator, yeah, I was looking for the correct words. I was looking for the correct words to say. In fact, I think in this day and age, you really shouldn't be testing some things. You should be testing people how they acquire solutions. It's just how you find out solutions. That's what you should be testing. People should be allowed to go into exams with Google. And the questions must be brand new and so interesting that if even Google, the textbook, nothing can help them if they don't know how to do it. So the textbook testing how you could take knowledge that you could get anyway and use it. Days of that is coming. The values of x that satisfy the inequality. Oh yeah, I think this question was a C. Circles, there's circles and there's circles in coordinate geometry. That's module 2, correct me if I'm wrong. Module 2. We come into that. Square. I always do this using one method. Now, for can't talk again. For add maths, they normally do something like this, and you just square, bring across on one side, form a quadratic, solve that quadratic inequality. For pure maths, they now want to play a little sneaky and put in the P. Alright, so P and X, I can't remember which way it was pointing. That way, great. So you're going to square both sides. And you're going to end up with, like when you're squaring here, it's 4x squared, right? 4x squared, 2 by 2, right? So negative 2xp plus p squared is greater than x squared. Bring across the x squared, you get 3x squared. Yeah, minus 2xp plus p squared. Factorize this. Everybody didn't hit the answers already. Just keep in mind that's greater than 0 now. So you're looking at this kind of curve. Minimum. So when you get 2 values, I wonder if you get the answer just based off of that alone. Minimum. Yeah, because they give you all the things here, man. So which one is higher? Or higher? Still need to know whether you deal with negative p or so you kind of need to go through and factorize it. This will be like 3x minus 3xp plus xp plus p squared is greater than 0. So it's now 3x. Jeez and ages. Tired. 3x into x squared minus p, not x squared, x minus p. Anything that's coming up my mouth right now. X minus p negative, what are we getting then? P here, negative p. So 3x minus p, negative p and 3, negative positive 3, P and 3, P and 3, P and 3 and P. Right again, P and 3 and P forward. Negative 4xp. I made a mistake. 2 by 2, negative 4xp. Two x squared. I still end up with the same thing. Right there. I'm picking. 4x squared 2 by 2 by 10. So I leave only 2 last time. Alright, minus 4xp plus p squared is greater than x squared. Bring this across. 3x squared minus 4xp plus p squared greater than 0. 3x squared minus 3xp minus xp plus p squared is greater than 0. Everything looking good there? Yeah, this making more sense now. So this is 3x into x minus p, x minus p, negative p still. Oh, p and 3 and just p. I still end up with the same thing by hook and the crookes. 4, negative 4, negative 4. Thanks to Hila and everybody. P and 3 will be the smaller one. And P here. And we want it for is greater than 0. Alright. Less than A. Alright, so P and 3. P. That's it. A little go down the rabbit hole like me in your exam. If you get a question similar to this, make sure and get enough sleep before your exam. Which of the following represents y is equal to the absolute of 1 and x? Oh yeah, this is the next thing that could be the train to module 1. Yeah, the faster way where you use the signs. But this fastener, I can do this in seconds. Which of the following represents y is equal to 1 over x? The modulus. A, I don't even have the letters here. B, let's tell you. C, D. But everybody know it had to be D anyhow. Modulus, I know nothing like any negative. This is quadratic, this is x squared. So this is the 1 and x graph. The 1 and x graph though, if you reflect it in the inverse of 1 and x, like y is equal to 1 and x, the inverse of that is the same thing. The inverse is the same thing. Keep that in mind, that could be tested. Last question. I'm so happy to see this last question. Asymptote will flip to positive, yes. Well, it asymptoting all over the place. Here. I went through this already sometime before in public. Last question, people. It's really. The roots of an equation, 3 hours exact. Wait, I think I had a normal person name. Shucks. You were just correlating. I like me. Sorry about that. Let's start fighting. D, everybody saying D, roots of the equation. This one a little tricky. Roots of the equation, the value K, the sum will be alpha plus 2, or you notice they're saying alpha for everything plus 3 alpha. Yeah, this is something that's come 6 alpha. So 6 alpha is equal to K. Sum of the roots, negative 6 alpha is equal to K. Cool. We can leave that there for now. Alpha plus product, right? So product. This is product, so this is negative as well. So multiply all these things for me. You'll get 6 alpha cube. 6 alpha cube is equal to, what is that, 162? 162 divided by 6. 27. So alpha cube is equal to 27. That means alpha is equal to, now negative, it have a negative in here. Because negative product thing, right. So I can put the negative here and wherever floating your boat out here, people. Real science to play around with this. So this is an easy question, it's just the science. So now I'm putting negative here now. Because the 6 come across, remember? Product would be negative and the sum would be negative. The sum of the product pairwise is the one that's positive. And the cube root of negative 27 can be done, that's negative 3. So good. Alpha is negative 3. So you can put that in there. Negative 6 by negative 3 is equal to K. Negative 6 by negative 3 is 18 is equal to K. Your answer should be A. Some people are getting D though. I guess when you reach here, you stop. Don't stop. They ask you to find the value of K and the value of alpha. Answer is A. Why is in the chat if you understand that? Thank you for coming to my TED Talks. That's all of module 1, give or take. I didn't really go much into summation. I feel like I could have 1 or 2 more questions on summation, so make sure you check out that. I didn't do much proofs like induction, but I have a whole video on that, and either way, CSEC don't really test proofs. And then they will get some even number thing, we do the even number question. Rate how much you feel you understand module 1 out of 10. How prepared you feeling you are for module 1 out of 10? Got an idea what going on here, and then we got call that George. You know, just we do this without any breaks. Did we have a break? Only when I went to carry Zion inside. If somebody could just go through this and actually know I do all kind of questions all over the place. But if you want, you can put like timestamps where important topics are. Go over again, please. Go over again this last question. Okay, Shanik. And you do some paper 3 pure maths. I wouldn't be able to do paper 3 pure maths, I can tell you that. Paper 3 maths is coming. CSEC maths, if you are one of those. Remember, this is the product, eh? This is the alpha, beta, gamma. But they're clever, they didn't put alpha, beta, gamma, they put everything as alpha. So beta is 2 alpha and gamma is 3 alpha. Don't let that frighten you. Cool. This is all the roots. Product of the roots is 162. So that's what I should have started off with in the first place. So alpha times 2 alpha times 3 alpha. This is actually 6 alpha cube. And we know that negative the product is equal to this number that stands by himself there. The product is equal to the additive inverse of that number, minus 162. Anyway you want to write it. So alpha cube is negative 162 divided by 6, we get 27. In other words, we boil that down, we get the cube root, negative 27. We boil that down, we get negative 3. Don't put negative 3 as the answer. They didn't ask it for alpha. They asked it for k. And k is the sum minus the negative version of the sum of the roots. So you add up all these things. So this is like negative 3 plus 2 by negative 3 plus 3 by negative 3. What we get? I think we get negative 18, right? Negative 18. But it's not negative 18 either, because remember the sum is equal to minus k. So it's negative negative. So real please sister lost yourself in this question. Practice it yourself and make sure you can get back to my answer. Then change up the numbers or something and try it for yourself again. Make sure you can get back a solid answer so that in the exam you don't just make a silly mistake with the sign. I find I see nice 8s and 7s and thing. I even taking the 7, 7, 8, 9, 10. That's good. Hopefully you can get the same number when you reach into the tricks. Until then, I'm here in front of the Father above. See you when I see you. Don't forget to press like. Don't forget to make a last share, last picture, last post. Save the video so that I can come back and listen it, put it on play before exams. These are original questions. It's just based off of my knowledge of what I know is come all the time, what students say is come all the time. So I will keep the video up. Infringing on nobody. Questions here. We're not doing the next 2 modules. TBA to be announced. We'll see. We have time. If it's a thing, we have time.